Yeah, Anish, Divya joined.
Sir. I was told sir she will join in 5 minutes.
So it's already 9 o'clock, right?
Sir.
Shall we make yours first if possible? Or should we wait for another 2 minutes?
Sir.
Shall we wait or shall we make.
We'll wait, sir. 9:15. I have told everyone to join.
Why 9:15? Yours is 9:15, theirs is 9 o'clock, right? Divya's is 9 o'clock.
Aha.
No, what you told to them?
Like I have messaged in the group, sir. Like everyone join at 9:15.
9:15 or 50?
1 5, sir.
Okay. Then I'll wait till 15. I think she'll join at 9:15.
Okay.
I told that it is at 9 o'clock, right? Even on the slide also I have written 9. I should have communicated properly. Anyway, we'll start at 9:15,
Nine
okay?
fifteen to 9:45.
Okay, okay, okay. Yeah, Santosh, it is at 9:15. Some miscommunication happened. It is at 9:15. Yeah, good evening, everyone. Thank you so much for joining here. So, now Divya is going to give the presentation on sector antenna, which is used for mobile communication. So, the presentation is for 10 minutes and 9:25, 9:15 it will start, and 9:25 it will get completed. And the 5 minutes is dedicated for discussion. I request the participants to at least ask basic doubts, because this is not a house together video. So just for 5 minutes or 10 minutes, you please concentrate and just try to have a fruitful discussion. And at 9:30, we will have one more presentation on mobile networks by Anish Radar, and he'll also present for 10 minutes. And after that, 5 more minutes we'll be having for discussion. And hardly we'll make it 30 minutes. If possible, we'll make it less than 30 minutes based on the way how the students present here. Okay, I'll start recording from now onwards. On these things, whatever I spoke, it is not in recording. It might be there in the live, but now I'll start recording. So now over to you, um, Divya.
So myself Divya. So this the presentation
One
is
second,
on
please. One
sector
second, please.
antenna.
One second, please.
So myself Divya. So this presentation is on sector antenna. So before understanding what a sector antenna is, we will understand like why we require this antenna. So we all know that a normal omnidirectional antenna, which will radiate the power in all directions. In 360 direction, it will be radiating the power. So if we consider a scenario in which we want a power to be radiated in some one particular region, like one side, say north, east, or west. So in that case, so the omnidirectional antenna, which is radiating in all directions, we don't need the radiation to be radiated all over the 360 degrees. We are wasting the radiation. So in that case, we will be using the sector antennas. So consider another scenario in which we require some stronger signals. So in that case, the sector antenna will be used. And also, if some antennas are connected nearby, there will be some interference will be there. So to avoid this, the sector antenna is the solution. So what exactly the sector antenna is? So sector antenna, it's a type of a directional antenna. The word itself, the sector word is itself is saying that it will radiate the power over a sector. Like generally, the sector antennas will be 60 degrees, 90 degrees, or 120 degrees. So the image over here represents the radiation pattern of this radiation pattern of the omnidirectional and this directional. So in this power is getting radiated all over here in 360 degrees. So the in the and in case of directional antenna, it will be radiating in some particular direction. So coming to the major parts of this sector antenna, there are four major parts. The first one is the radiating elements, feed network, reflector or backplane, and radome. So the radiating element, the central part of this is called the radiating element. So we will be getting a signal from a transmitter, right? So the signal will be an RF signal, the radio frequency signals. So to convert this radio frequency signals to electromagnetic waves, we require these radiating elements. So this will be an array of some microstrip patch antennas or dipoles. So coming to the feed network, so here, like the red and blue points over here are called as feed points. So through these feed points, the feed network will be connected over here. So the main function of this feed network, so it has to distribute the signal, like it has to distribute the signal all over these radiating elements. So we will be getting a radiate like signal from a transmitter, right? So that will be radiated, like it will be equally spread over. It will help to spread the signal over the radiating element. So coming to the reflector, or it is also called as a backplane. So the sector antenna is means what, like it has to direct in some particular direction, right? So here it has to prevent some backward radiation. So the reflector is used to prevent the backward radiation. So radome is the protective cover. So it will protect the sector antenna from various environmental parameters like temperature, pressure, humidity, and all those things. So generally, this is made up of plastic or fiberglass. So why we are not using like metals or any other material as a protective cover is that, like, so in metal case, the waves, like the transmitter will be transmitting the like RF signal, right? So it will be like getting affected if we use some other materials. So plastic and fiberglass, it doesn't affect the radio waves. So this is the overall picture of the sector antenna. So these are the radiating elements, and this is the radome, the protective cover, and the reflector, this plane over which these radiating elements are placed. So this plane is called as the reflector. So the feed network. So the red network is the receiver, and the blue network is the transmit. So now we will look towards the working principle of this sector antenna. So first, like the signal will get feed. So feeding the signal. So RF, the transmitter will send an RF signal. So now this signal will be transmitted through the feed network. So this what does the what? So the next step, like distribution across the elements. So the signal which is passed to this feed network will be equally distributed over these radiating elements. So the signal will be having a control phase and an amplitude. So by tuning the phase and amplitude, we can change the beam direction and the beam width. So so phase can be controlled by a phase shifter. Basically, this phase shifter is an electronic device. So then amplitude can be controlled so that we can adjust the beam width and side lobe levels. So in order to reduce the amplitude, we can use attenuator. So the next step will be the formation of the beams. So the radiating element will be like forming the electromagnetic waves, right? So these waves will interfere to form constructively in some particular direction. So that will be leading to some like a main lobe. So the power will be also getting like radiated in the sideways, right? Like here, the power can be also be radiated to through this sideways. So this side, like opposite direction, will get cancelled out, and the overall power radiation will be in this direction towards the upside. So the result, the antenna will form some main lobe of radiation covering a specific sector of the space. So as I said earlier, like reflection and focusing. So the meta reflector will be ensured that backward radiation won't occur. So coming to the sector antenna parameters. So the first parameter, the radiation pattern. So the pattern of the sector antenna is horizontal fan shaped beam. So this is the 3D pattern of this antenna, and these are side, front, and top views of this antenna. So here, like in the azimuthal, the radiation pattern, like the sector for the azimuthal plane and the elevation plane, here we observe that the beam width is 65 degrees. So here over in this picture, you can see that like the beam width is 65 in the horizontal plane, and whereas in the vertical plane, the beam width is less compared to this horizontal plane. So why the beam width will be more in this horizontal or azimuthal plane is that, so the users are in the horizontal plane, right? So we want to cover more users to more like more use, the coverage area should be the ground level, right? So if we like if beam width will be more in the elevation plane, so the power will be getting wasted in the, like it will be radiating towards the sky and or else like ground level, like completely ground. So So we won't need that. So that's why like horizontal or azimuthal plane, the beam width will be 65 degrees. So half power beam width is 65 degrees and full null beam width is 120 degrees. So input impedance. So the input impedance of this antenna will be of 50 ohms. So what this input impedance exactly is means that, so the transmitter will be like sending the RF signal. So on receiving the transmitter, so there will be some losses, right? So the losses will be due to the heat, like in the form of heat, and some of the radiation power will be near the antenna, so that power, so considering all these losses, so so impedance will be like a particular impedance will be like given considering all these losses and all. So in order to get maximum power, like the input impedance should match, like the load impedance should be matching with the input impedance. So coming to the gain will be 12 to 20 dBi. So the dBi means decibel with respect to the isotropic antenna. So for omnidirectional antenna, the gain will be less, like around 2 to 8 dB in that range. So coming to the power handling capacity, so how much power antenna can handle safely. So that is the power handling capacity. So generally it will be 50 to 200 watts. Coming to the efficiency, so it is typically greater than 85 percentage, and the front to back ratio is greater than or equal to 25 dB. So the what this front to back ratio means that it's the ratio of the power which the in the forward direction to the ratio of the power in the backward direction. Now polarization. So the polarization, which will be dual slant polarization. So the polarizations, like we know types of polarizations, right? Like linear polarization, circular polarization, and elliptical polarizations. So in dual slant polarization means that like polarization will be in plus 45 and minus 45 direction. So these are the operating frequencies for the 2G. So 2G, the operating frequency is 900 megahertz. For 3G, it's 1800 megahertz. So for 3G, we will be using WCDMA technology, that is wideband code division multiple access. For the 4G, the operating frequency is 700 to 2100 megahertz. So we will be using OFDM technology in this. So these are the application of the sector antenna. So like we will be using sector antenna in cellular base stations. So for 360 degree coverage, we will be using sectors like 60. So three sector antennas will be using, like, sorry, 60-degree sector antennas, 60-degree sector antenna will be used for 360-degree coverage. So we can like, why we are not using the, like for 360 degrees, why we are not using omnidirectional. So why we are considering the sector, because like the gain will be less in case of omnidirectional. So in case of this sector, by using the three sectors of 60 degrees, so we will be getting some more power, like more gain. So for better capacity and coverage, we will be using this sector antennas for 360-degree coverage. So in wireless broadband, we will use the sector antenna. So for multiple point communication, so in rural networks, the communication will be happening through this multi-point communication. So in that we will be using. And in radar and surveillance system, so for like to track some particular target. So in that case, we will be using also for industrial and commercial network. So to cover some like limited angle regions, like in factories or ports or warehouses. So in transportation systems, we'll be using the sector antenna. So highway monitoring, to monitor like whether the vehicles are going in some limited speed or not. So if for that we will be using this antennas. So for also for V2X communication. So V2X communication means like vehicle to infrastructure or vehicle to vehicle communication. In that case also we will be using this antennas for defense and military purpose also. So it's also used in campus and educational networks. So to cover to provide the Wi-Fi coverage over hostel, classrooms, and departments. So this is all about the introduction to the sector antenna.
Yeah, now open to discussion, please. Any questions or any queries, please switch on your mic and ask. One point I would like to say here, she specifically mentioned that the gain in DVI, right? So DVI means, so we are going to calculate the gain with respect to the isotropic antenna. Practically, what happens, the gain, uh, practically the gain will be calculated with respect to some reference antenna because isotropic antenna is not practically realizable. So some reference antenna whose power radiation is known, that reference antenna people will take, and with reference to that reference antenna, we'll try to calculate the gain. So in that context, people will not write the gain as a, dBi; they'll just mention it as dB because the gain is calculated with respect to some by taking some other reference antenna. I hope you got what I'm trying to say. The thing is, instead of isotropic antenna, which is used for calculating the gain, some reference antenna whose characteristics were known, that will be considered as the reference antenna to calculate the gain. In that case, we will be giving the units as only just dB. The gain is 20 dB, 30 dB. That's it. If it is isotropic, then we will be writing it as dBi. It's not always required to have the units as dBi. Sometimes the gain units can also be dB. In that case, the reference antenna is not isotropic antenna, it is something else. Okay. So any other questions? If you have, please post it in the chat. Meanwhile, we will try to switch on to the next presentation by Anish. Yeah, Anish, over to you.
Yes, sir. So is my voice audible and screen visible, sir?
Yes, please keep it in a full screen mode. Yeah, now it is fine. Go ahead.
Hello everyone, I am Anish from EC department. Today I will be discussing about the mobile network parameters. Before going into the topic, I want to raise a few questions among the audience. So my questions are like, how does the phone knows with which tower it should connect with? And who monitors this spectrum usage, this 60 hertz, 600 megahertz, 700 megahertz, 2100 megahertz, that only this carrier should use and that carrier should use in that region? And what are the cost of the spectrums? And is the cost of the spectrum same? Okay, let's see. A small task for the audience. If you have the Android phones or iPhones, just dial this number. I'll giving 1 minute of time. Just dial this number and check what it shows. For all mobiles, it shows interface. For new mobiles, it may not work. So, yeah. *# 3646 ###. And for iPhone, it is *3001 #12345 #. So if you have dialed this number, then you would have seen some interface like this for the Android and this interface for the iPhone. My point of interest is in discussing what are these parameters in this session. Let's see what are these parameters in detail. So whatever the dashboard you are seeing here, it is known as a field test mode. In this mode, the phone will show you like what are the parameters it is measuring from the antenna. So the first one, what we have here is its carrier. It tells about the service provider of your SIM, whether it is Airtel, BSNL, Geo, or some other network. And the second one is TAC. TAC is known as tracking area code. The total area is spread into several hexagonal shapes. And in each hexagonal shape, we have a cell tower. And this cell tower is placed in such a way that it covers the whole hexagonal. So when the person moves from one region to other region, so there will be proper handoff handled by the tower, so that you won't experience any interrupts. So this tracking area code. So each hexagon has one unique code ID, and that is given by this number 31382. And the next parameter is network PLMN. It's public LAN mobile network. So here you see you have a 3-digit number and a 2-digit number. The first 3-digit number is 404. It represents the country's code. In our case, it is India. And the next 2 digits, it represents the service provider. Because of this number, it knows that the carrier is BSNL or Jio or Airtel. And then the next one is a phone number. Phone number, like every phone has its own unique number. And the next one is LTE, long-term evolution. Here we have some parameters: band, bandwidth, cell ID. Before going into the band, let me explain you more about this. So everyone knows this electromagnetic spectrum, right? In that we have radio waves. The range is from 3 Hz to 300 gigahertz. And these frequencies are divided into several bands: band 1, band 2, band 3, band 4, band 5, band 6, and so on. So out of those bands, my phone is using band 8. And this band 8 corresponds to 900 megahertz. And the next is bandwidth. In that band 8, my phone is not using the entire spectrum. It's using only a spectrum of bandwidth 20 megahertz. If you see, like in the phone, we can talk simultaneously. Like it's a duplex communication. At the given time, both people, sender and the receiver, can talk at the same time. So that is known as a duplex. If only one person can talk at one time, it's a simplex. So here the user can talk simultaneously. So it's duplex communication, and we are using a frequency division, FDD. It's frequency division duplex. And in this we have two, uplink and downlink. So uplink is the message will be sent from the sender to the receiver, and the downlink is when the message will be sent from the receiver to the sender. If you see here, the uplink is 880 to 915 megahertz, and here the downlink is not starting from the 915 megahertz to 960 megahertz. Here some space is given. Here it is 915 and here it is 925. Here the space is left because to avoid the interference. At the same time, this guy will be talking and this guy will be talking. So to avoid the interference, we will be leaving some space, and this is known as a guard band. Whatever the band between 915 to 925, it's left open, like it's not allocated to any network service provider. And next we have cell ID. In the
Anish,
area code.
Anish, 1 second here. I just want to know who is the sender and who is the receiver, specifically in the case of uplink and downlink. Who is the sender and who is the receiver? You just clarify what is uplink and downlink a little bit more.
Okay, so if person A is talking with person B, so the person A will be talking to the person B in this frequency. The message will be sent in this frequency range, and whatever the message the person B is sending to A, it is sent in this bandwidth. So why we cannot use the same range 880 to 915 spectrum? Because it will cause interference. At the same time, person A is talking and that message is encoded in this spectrum, and same time person B is talking and that frequency is encoded in the same spectrum. So it will be difficult to modulate or demodulate or detect what message is encoded in that. And that's the reason, to avoid this interference, we are using separate spectrum.
I have a small correction here. Uplink means it is actually you see, as mentioned over here in the hexagonal sites, cell sites, we are going to have cell tower. So when user tries to
Yes.
transmit, mobile user means whether it is me or you or whoever be the person who is having the mobile, if they are going to transmit to the tower, then that is considered as a uplink. And if tower communicates to the user, that will be considered as a downlink. So you just make a note of this small correction. So downlink means it is from the
Yes.
cell tower to the user, and uplink means from user to the cell tower. Please continue, Anish.
Uh, Thank you, sir. Thank you for correcting me. Uh, the next parameter is cell ID, and each cell tower has its unique ID, and that is given by this number here, the number over here. The next parameter we have RSRP, RSRP. This is reference signal received power. Uh, What is RSRP? Like the phone, it takes the signals from the tower. In that the signal whichever the tower is sending, it has so much noise, interference, and the message encoded in it. Out of the total power which the cell phone has received, only some amount contains the original signal, and that is given by this RSRP. Here you can see it is around minus 110 dBm. So if you convert into power, it's about 10 power minus 14 watts. So this much of energy, our phone is able to detect it and decode it, and is able to send us the signals, and we are able to talk. And the next parameter is RSRQ, reference signal received quality. Out of the total power which the phone has detected, its reference signal strength indicator, only some amount of it has the useful information, and the ratio of RSRP to RSSI multiplied with N, it gives the uh, received quality. And here N represents the number of the blocks, and each block corresponds to frequency range, spectrum of frequency range. And here you can see the values. If it is RSRP value is greater than 90 dBm, then the signal strength is good. And if it is in between minus 90 dBm to minus 105, it's average, and so on. Here in this case, here you can see it's around minus 110 dB. I checked this from my hostel, so it's very poor. So the Airtel signal is very poor near my hostel. And the next one, everyone knows IPL auction, but do you know that even the radio spectrums are auctioned, so that the each network service provider will pay some money to the government and will use that specific allocated spectrum for the uh, for providing the service to the customers. Here I have taken the auction report of 2022. Here you can see each state is listed in this column, and that corresponding frequency spectrum in here, and the rate of the spectrum per block. Here per block means it's a range of frequencies in that 26 gigahertz band. And here you can see the cost is around 28 crores per block. So the same 26 gigahertz in Andhra Pradesh, so it's around 28 crores, and around Assam, it's 5 crores, and so on. Can someone tell me why in Andhra Pradesh we are using 26 gigahertz? In Assam also they are using 26 gigahertz. Won't these two interfere? Let's see what happened. How we are able to use the same signal, same band in two different places. And I have taken some bands like 26 gigahertz, 700 megahertz, 800 megahertz, megahertz, and their costs here. If you see clearly, for the 700 megahertz band, the price per block is around 1590 crores. Can someone tell me why the cost is so much higher in the 700 megahertz range? if you listen to the last presentation by Divya, this 700 megahertz is corresponds to the 4G spectrum. So many carriers are competing for the 700 megahertz. So the price is very high. And the other advantage of using 700 megahertz is as the frequency is low, it can cover more area. So that the carriers will have to put less towers to provide to cover more area. And we can see 21 megahertz is around 710 crores. And again, if you see clearly, that 2300 megahertz is around 590 crores. If you see why this is high, it corresponds to the 5G spectrum. In the 5G spectrum, the distance covered is relatively low, but the data rate, the bandwidth is very high. So that's the reason, like it's always the trade-off between the distance covered and the bandwidth. Bandwidth by the sense, how much speed the communication is, like the data rate is. Here I have taken the final auction ranking. You can see Airtel has spent around 42,000 crores in this auction, and Vodafone has spent around 15,000 crores, and Jio has spent around 85,000 crores. So 85,000 crores just for auction, not for, and to maintain the cell towers and all, and it requires much more expenses than this. And this table over here, it summarizes why the costs are high. Like if you see 700 megahertz, the data rate is okay, but the data rate is not that much high when compared to the 2300 megahertz. But here the coverage is very excellent. In the 2300 megahertz, the coverage is not that much when compared to the 700 megahertz. So to provide the better service, the carrier has to buy the corresponding spectrum. So it has to buy the spectrum in this range to give good coverage, and the spectrum in this range to give better speed for the customers. So it will balance this both. And some more questions to ponder. Like, can anyone produce any frequency they want by using, in the lab we have resistors, capacitors, and the voltage sources. Can we generate any signals with any frequency? And suppose if you buy a spectrum in India of 600 megahertz, does that mean no one in America can use it? Let's see the answers for this. So if you have the resistors, capacitors, like it's not like you can produce any signal you want, because there are three telecommunication organizations which monitor this. The first one is TRAI, Telecommunications Authority of India, Telecommunication Regulatory Authority of India, and Department of Telecommunications and Wireless Planning and Committee. So this will constantly monitor like how much, who are using which spectrums, like is there any invader using that spectrum. So by this, each department will do its duty, and this will be regulating the whole communications in India. That's it, sir. Thank you.
Yeah, Anish, what is the WPC? The last link which you have given, DOT is fine, and the other one.
WPC is a Wireless Planning Committee, so like it monitors all the usage in India.
Okay, fine. So across the world, it is FCC, Federal Communications Commission. Okay, it is going to give the spectrum assignments to different countries. Yeah. Now questions to the from the audience, please. Actually, I would like to thank even Anish also for giving the nice presentation. And special thanks to Divya. Yesterday also she gave the presentation, and somehow we make it better today. Any questions from the audience, please? Yeah, if no questions, yeah, please, please,
Sir,
Anish.
here I want to highlight one thing.
Yes,
Like
please.
these band spectrums which are used are licensed specific area. So for Andhra Pradesh, 1800 megahertz, whichever carrier it buys, that will use it. For Assam, the same 1800 megahertz, if some other carrier buys it, it will use. Why simultaneously they can use is the signals which are present in the Andhra Pradesh, they will be highly attenuated by the time when they reach Assam. So that's the reason here the frequency is reused. So this is one of the frequency reuse concept.
Yeah, I would like to add one more point here. You people, I don't know whether you know it or not. Ham radio, ham radio. This radio is used specifically during this natural calamities time. Whenever the complete network gets disaster, you can able to still operate this ham radios. There is an association linked with ham radio. Maybe if someone is interested, you just try to explore what ham radio is and what are its features. So many activities are being conducted under this ham radio. So you please try to. You can even get the license of to use the ham radio frequencies also. Okay. So if anyone interested, you just have a look on that. Thank you so much for tuning to this, and we will try to come back over here tomorrow. Thank you all.
Thank you.